Alright, let's continue our discussion of kinetics by now getting into the gas laws. The gas laws all relate to changes that we make in properties of enclosed gases. So, starting off here, you need to be thinking about a gas in a sealed container. Okay, so using this little simulation, you can see we have gas particles and they're in an enclosed container. So those particles, you see them, they're bouncing around, they're moving in rapid random directions, okay? And what we're going to do is we're going to make a change, okay? So first, we're going to push in on the container, okay? We're going to squeeze that container. We're going to apply a force, and that causes the volume of the container to decrease. So we'll do that now. We will push in, the volume of the container goes down, and you notice the proximity of the particles gets smaller and smaller. Also, the thing to note, we're keeping temperature constant in this case. We're only looking at two factors, comparing our volume to our pressure. Now previously the pressure was around 0.25. If you look at it now, you'll notice that there's been an increase. So let's see why that happens. First off, since we have a smaller volume, there are going to be more collisions. There's less space between particles, so fewer collisions result. These increased collisions are reflected as a higher pressure. Okay, so we have more collisions across the same span of time. That results in an increase in pressure. Now, I want you to consider that same gas, but this time around, what we're going to do is we are going to apply some heat to this container. Okay, so we'll apply some heat. Let's see, let me show you here. So by applying heat, it raises the temperature of those gas particles. The increase in this temperature is an increase in energy, because remember, our temperature is actually a measure of energy, of kinetic energy. Okay, so the motion energy is temperature. If I raise the temperature, what we're saying is the particles are going to move faster. If these faster moving particles collide, they have more energy, so they hit with more force, and the pressure will be higher. So let's see with our simulation how that's going to look. I want to increase temperature. So we were at 300 degrees. Now I'm going to raise that temperature up. And you notice we went from a 0.5 pressure value up to around 1.3. So an increase in the temperature increases the speed of our molecules, and that in turn increases the pressure. So next, we want to consider another pairing of factors. What we're going to do is we are going to think about instead of a change of temperature or pressure or volume, I should say, what we're going to keep constant in this case is we're going to say that pressure does not change. Okay, pressure doesn't change, but I'm going to modify the volume. When I modify volume, okay, so, I guess we're doing temperature here. If we place the container in an ice bath, it's going to decrease the temperature of those gas particles. The decrease in temperature reduces the speed of the particles. And in order for us to keep the pressure constant, the thing that must change is the volume. So let's do that now. We're going to keep pressure constant, and we're going to cool this sample now. So we're going to take away heat, put it in an ice bath, and you notice as I take away heat, my volume is getting smaller and smaller and smaller. It contracts in. So here's what we're going to do now. We are going to look at how these three relationships look when they've been combined. So mathematically, here is what we've discovered so far. First, our pressure and volume relationship. As I increase pressure, the volume goes down. So the way that those relate is my initial pressure multiplied by the initial volume is going to be equivalent to the new pressure times the new volume. So if one goes up, the other goes down. If I consider my pressure and temperature, if pressure went up, temperature also went up. So the way that we look at that mathematically is P1 divided by T1 is P2 divided by T2. Now the third variable again was volume. If I were to increase volume, temperature increases as a result. So that shows that V1 over T1 is V2 over T2. Looking at all of these factors together, we get initial pressure times initial volume divided by initial temperature is equal to my second pressure, second volume, and second temperature. Remember that absolute temperature relates directly to kinetic energy, so we have to convert all temperatures to kelvins prior to solving these. Okay? So I'm going to let you guys go ahead and work these out. I'm going to make a second video that deals with practice problems because it's already been a little bit of time here.